In this video, you will learn the basic skills needed to create 3D models in CAD so that you can use them in your DIY projects, such as robots, drones, and more. You'll also learn how to take those designs in software and bring them to real life using services like PCBWay, the sponsor of today's video, or 3D printers if you have them. You'll also see how those skills are applied to a real life example of an object avoiding robot.
Okay, so to get started, we're going to talk about what CAD is.
Well, it stands for computer-aided design, which means that we can use computers to design certain things. In this video, we are using CAD to design physical mechanical objects, which, for example, could be a chassis for a robot or a baseplate for an electronic board. In a future video, CAD would be used to design PCBs.
So now onto the CADing process. Here's a basic breakdown of what we would do.
We first make a 2D drawing and then make the size and features of that drawing to have the desired dimensions. Then we can take that 2D drawing and stretch it out into a 3D shape. There are many different ways of stretching which will be covered in this video. Then we repeatedly draw 2D shapes on existing 3D shapes to add on material or take away material until we get what we want. This is great and all, but what CAD software would we use to do all this? There are many out there like Onshape, Autodesk Fusion, or SolidWorks, but today we'll be using FreeCAD because it's free and was made to be that way. Most CAD softwares are similar to each other, so the skills learned here can transfer over.
All right, you can choose to download FreeCAD and follow along, or you can just watch, soak it all in, and try it out for yourself later. Now, just FYI, I'm not gonna be showing you how to download FreeCAD because it's just like any other application you would download, and also, you guys are smart enough for that.
All right, so once you get into FreeCAD, you're gonna wanna create a new document, and then we want to start a sketch. So basically drawing 2D shapes, similar to how you sketch on a piece of paper. And then you can press any plane that you want. I'm just gonna press the XZ plane. We can create points, so like 0-dimensional points. You can also create lines, things like that. But a more useful thing, if I were to just delete all of that, is to probably create polygons or shapes. So I'm just gonna start off like, sort of like that. So now we have a 2D shape, and how I'm doing this is I'm pressing the middle and right mouse button. Middle mouse is drag, and then right mouse combined with that is to rotate. We can also, instead of doing this, there's also creating shapes with presets. So like you can create a circle, or you can create rectangle just by pressing 2 corners or 2 points like that. You can also create polygons. So all of these, or a regular polygon, which means you can specify how many sides you want. So now we have the ability to make 2D shapes, but now we want some precision because we are making engineering projects, even if it may be DIY. Okay, so now we want to make a box or something that is pretty regular and not random like this. One of the first things that we could do is to make all of these sort of like parallel or perpendicular to each other. So we can use this here, constrain horizontal or vertical. Constrain horizontal means that it will make lines horizontal to our screen, and constrain vertical is the other way, vertical. And now you can start to see how this is a rectangle, but we want everything to be measured and precise. So that's where the dimension tool comes in. You could dimension, I don't know, 100 millimeters or whatever units you want. Probably use inches. Now that's way too big. It's a bit too big for me. I just want a small little box or something like that. So yeah, and the goal in FreeCAD is to have this box become green. If it's all green, then it's fully specified. Down here, it says we're under constrained by 1 degree of freedom. The 1 degree of freedom is that we could still move it left and right. So to fix that, constrain coincident essentially matches 2 points together locationally. So if we want this point to get stuck with that point, then we could do that. And now it's green and it's fully constrained. That's what we want. Now we have our very nice rectangle. Let's say for some reason you want this point to be in the middle of this box. You could do that a few ways. You could do that with the dimension tool. But in engineering, there's always multiple ways that you can do stuff. Another way is to use construction geometry. So if we toggle that, if you were to connect it up like this, so we align like this, And now it's not directly in the center of this rectangle. What we could do is we can constrain equal, which makes two things equal in length or whatever dimension. So if we do this equal to that, it'll be the same length, which means that has to be halfway. Same thing for horizontal, and we have the same exact effect as before. That's a very advanced way, I guess, of making just a simple rectangle. You could literally just do this and you're done. Or actually, you could do this and then you could specify 150 and then press tab to do the other side, and then bam, you're done. But who knows? Maybe you need some advanced tools for whatever reason. All right, so we have our 2D drawing. Now let's make it 3D. We can do this by extruding the 2D shape, essentially stretching it into a third dimension. There are multiple ways of stretching, which results in different shapes. So let's see what these do. All right, so we have our rectangle, which is not very interesting. If we press on that rectangle or that sketch, we can make it more interesting. So I'm basically using the scroll wheel to show you the different ways we could stretch out that 2D shape into a 3D shape. And that's basically what we're doing. We draw 2D and then we stretch it out into 3D. So that's called pad. It essentially just takes a shape and stretches it out. This section right here is essentially the 3D extrusion section, I guess. So you can make 3D stuff from 2D shapes here. Essentially for revolve, we're gonna need this shape to not be at the origin. So this is at the origin. We don't want that. So I'm just gonna move this and I'm gonna use the dimension tool to specify how far away from the origin we want to be. And then I'm gonna want that to be halfway, just so that I guess it looks kind of nice. So now if I press this sketch and I try and revolve around the x-axis, revolve axis intersects the sketch. Okay. Oh, there we go. So horizontal sketch axis is going to be like in this direction, I believe. So what I'm going to do here is I'm going to change the angle and you'll be able to see how revolve works. You can kind of see how we could go from a 2D kind of shape into a 3D shape. So let's say you want to cut out some holes, some more holes in this wheel. What we could do is we can draw more 2D shapes on top of it. We can just select a surface, create a sketch to make 2D shapes, and then we can just draw a circle using the circle tool. And I don't know, maybe I just want a ring of these circles or something like that. So I guess to create a ring of these, maybe of 6 of them, I'm actually going to use the construction geometry that we have used before. I'm going to create a hexagon because it has 6 points, just like that. So that's how we're going to do it. So this is all construction geometry. It's all invisible. If you go into this or out of the sketch, it's not there. It's just to help place things or to align things. So now all we have to do is select our real, the non-construction geometry circle tool. So now we could just place circles on those points. And then the cool thing about CAD is it's like, oh, maybe I want this thing to be bigger. This ring of circles to have a larger radius or smaller or whatever. CAD will be able to do that. And to make it look nice, I'm going to make all of these circles the same size. So I just relate all of the dimensions together using the equal tool, and now they're all the same. And now I can go in and dimension one of these to have a diameter of, I don't know, 15 millimeters. And all of them will have that because they have this constraint that they're all the same diameter. Very nice. Okay, so I guess I'll want this ring of circles to have a diameter of 150. Why not? Because it's a nice round number, and that kind of looks nice as well. So now we have a ring of 6 circles, and it's all like dimensioned and proper. So now we can take that and subtract or pocket those circles. So you could go through here instead of trying to figure out what length you need to go through all. I mean, one way is to just do like a ginormous number so that it goes through all of it. Or if you don't want to do any of that, you can go to the type and then through all, and that just goes, as it says, through all. So let's say you want to round out your edges. So we can subtract some additional material, if you want to think of it like that. Go down here and we can make the radius of that sanding or rounding off larger. So I guess 30, why not? What if you don't want a rounded surface? Maybe you want a sharp edge. That's where the chamfer tool comes in. We can make a 45-degree cutaway like this, sort of. But maybe if you don't want equal distance, you can do two different distances. One of them is going to be in one cardinal direction. Seems like this size right here is the vertical cutaway direction. And then size 2 is the horizontal. Okay, so let's say we have this thing right here, and we want to merge it with another thing, which is going to be kind of interesting. So we have these things called datum planes, and they essentially allow us to draw sketches on other parts of the 3D space. So if we click on that surface, it'll create a datum plane that kind of fits on top of that surface. If we change the Z direction, we can make it go away from that surface. So I'm just going to make that 100. And now we can draw on this surface that we've created, just like any other time. So I'm just going to create that real quick. The next thing that I want to show is loft. So if we try and create a loft here, add a section like that. So you're essentially selecting two shapes right here. So if for some reason we want this circle, the highlighted circle there, to merge with that square or rectangle, then we can do it. We have two 2D shapes. We select both of them. You do sketch 2 right there. You select both of those 2D shapes, and then you can have them merge into each other. The computer kind of figures out how to do that, which is pretty cool. Okay, so completely new object. Let's just say you spent so much time making this shape. Let's just say it took a long time and you don't want to make it again. And then you realize, I actually need another one of these on the other side, and it has to touch, this plane right here, or that little rectangle. Well, fortunately for you, there's something called mirroring tool. So let's go to the mirror tool. Well, first of all, we need to select a plane to be our mirror. So essentially, it's like making our own mirror. So select reference if you want to make your own mirror. And as you can see, it made a copy of it just like that. It kind of looks like a crown. I actually didn't intentionally do that, but whatever. So there's a lot of other tools that we can use. I'm just going to create a sketch on the top of this surface. The other thing that you can do in 2D Sketch is to create external geometry, which essentially you're able to take edges from the 3D shape that you're drawing on. And this is very useful if you're trying to create sketches on top of other 3D shapes. So now we have these points or lines or edges from the 3D shape below that we can select from. And then you can use, if we create a pocket of this, you can create polar pattern. With the linear pattern, we can select a feature that we just created, that pocket. We select the linear pattern, and then we essentially define with the direction which way we want to copy those circles. So I want it to copy in this direction, so I just select an edge that represents sort of that direction. Now I can specify a length. I don't know what 25 will do. So you can kind of see over here, it copied it, but it's off the edge of the object. So I'm just gonna go in the reverse direction, and there we go. If I go a bit farther, like 100 millimeters, you can define the start and then the end point 100 millimeters away, and then you can increase how many times it copies over that distance. There's another thing that we could do, and that's called a polar pattern. If we use an axis here, we can select our spinning point or revolving point. So let's say we want to have a polar pattern around this vertical axis right there. So that means that if we selected our pocket and we increase this, let's see. Yeah, okay. You can kind of see how that works. It creates copies of this circle of our feature, whatever it may be, around this axis or central spinning point. So yeah, you can use this tool to create a pattern around an axis. Great. We can design a singular 3D model, but you can imagine that a robot, for example, has more than just one part. So how can you use CAD to combine multiple parts so that you can see how they all fit together in an assembly? Well, for FreeCAD specifically, there is a library called A2+ that allows us to create virtual assemblies. There is a plugin that you can use, an add-on, in the Tools and Add-on Manager tab, where you can do that. But I generally use A2+. You can search that up. I already have this installed. You can just search it up, press here, and then press install up here. So I'm going to use parts for a self-balancing robot project to show how to make assemblies. You should find it in our part design tab, which we can change to A2+ tab right up here. And what I'm gonna do, I'm essentially going to add a part from an external file. So I'm gonna import a chassis. This is actually for my self-balancing robot project, a previous video. We imported that into this assembly. And essentially we create a new file, just like we did for every other file before this one. So I start with the chassis here, very nice. And then I can put in a PCB assembly. So this PCB was designed using KiCad, and I can export it with KiCad and put it inside of a CAD software. Hopefully it doesn't crash because there's a lot of things going on with this. Okay, so we're back. Let me just click so that it gets placed somewhere. There's still a few other things that I want to load in. So one of those is a standoff, which is a very basic cylindrical looking thing right here. And I'm just gonna press that object and Control-C, Control-V it, copy, paste. 3 times in total. And these standoffs are pretty useful. If I double click on the object, I can move it around so that they're not all clumped together. So I'm just going to do that real quick. And now we actually want these things to be aligned to these holes so that we can properly see how it all works together. So how we do that is we essentially select an edge like that would fit in or fit around this edge right here. And essentially what we say to the CAD software is we want them to merge together, to like kind of move to match up and couple with each other. You can use that with this tool or that tool. Multiple tools generally work. I'm just going to use this one. Okay, there we go. It popped into place. So just accept that, obviously. And you do the same thing for all of the other standoffs. So I'm just going to do that now, but process is exactly the same. Okay, and for the PCB, literally the exact same thing. Okay, so we have a pretty basic chassis with its PCB on. Let's say we want to add some motors, so we can do that as well. Sometimes before you connect things, you need to align them so that they actually come in correctly. What I mean by that is, if we were to align the edges like this, it would not work. You would have to rotate the object so that it is in the direction that you would want it when you merge the two objects together. So in this case, we want this axle and this cylinder to fit into those two holes there, respectively. So we orient it, and now we can do the same exact thing. We want that edge to intersect or to mate with that edge. And then we wait for it to do its calculations. And there you go. So yeah, this is a partial finished design, but essentially you do the same exact thing over and over again. All right, so the cool thing about assemblies is that you can actually, if I go into here, you can go into one of your parts, for example. Okay, so let's just assume that for some reason you want to get rid of these very nice filleted edges here. So for that, we get rid of, we get rid of this right here. So if I just delete that, then when we go here, we shouldn't have that anymore. And the point is that if we change the model or a model here that's inside of an assembly, then we should have that same change in the assembly. So how we do that is we just make the change, we save the file. And so when you go into the assembly, it's not going to change instantly. You got to do one thing first. You're gonna need to press on the part, go into A2 plus, and then press on this refresh sort of tool over here that updates the parts. Okay, there you go. So this is generally what's supposed to happen here, is we changed the chassis from the fillet to no fillet, and we see that here if we press this button to update whatever part we want.
So with these skills, you can make a vast majority of DIY engineering and robotics projects. Well, on the mechanical side of things, of course.
The question now is, how do we get our design in our computer into the real world? For that, we can use a 3D printer, which generally involves getting the 3D model file, sending it to a 3D printer, and printing it. What if you don't have a 3D printer? You can use the services provided by PCBWay. Not only do they make PCBs, they can also manufacture 3D model designs using 3D printing, CNC milling, sheet metal cutting, and injection molding. For 3D printing, you can export your file as an STL file, send it into PCBWay, and select the basic 3D printing options. Now, this video isn't about 3D printing, but generally speaking, PCBWay's default options should be enough for DIY projects. Okay, back to the video. Alright, so let's see how we can use the skills to make a base plate to mount a PCB. So how would you go about making a chassis or a base plate for this PCB? We're going to start off by taking some measurements so that we can know how big to make the rectangle and the holes. So you can use this measure tool right here to measure CAD files, which is pretty nice. So we find out that to be 100 millimeters. So we save that length, and then about 60 millimeters there. I just got to select you. There we go. The radius is 2.5 millimeters. And that's pretty much all I need to make a rectangle, 100 by 60 millimeter rectangle. So this should be pretty easy. Go to part design, close out of that measuring tool, and select our plane, whatever we want. So I'm going to do this. I'm going to select the origin there so that it's constrained. So 60 millimeter, and then we said 100, I'm pretty sure. So we have our rectangle there, and now we can just extrude that out, whatever we want. I will need the distances between these holes and from the edges as well. So to measure between two holes, you can select the edges of those two holes and it'll know what you're trying to do. So select this one and that one. So now the center of those holes are 45 millimeters apart. Okay. So 85. So from the center of that hole to the edge is about 5 millimeters. There we go. So now we have that. Now we know where our holes should be. So I'm just going to save that. Go back to this document and we can start to create just 4 randomly sized circles. We all know that the holes should be equal. And then diameter should be 5 or radius of 2.5. I am going to use construction geometry because these circles are essentially in a rectangle with the dimensions that we found before, which was 45 millimeters and 85 millimeters. All of these have to be 90 degrees. So I'm going to do that with the constrain horizontal or vertical. So there we go. Now it's all nice and rectangular. That one's already 45, nice. And then 85. So we need 7.5 there, that looks better. And 7.5 there, and it should be all centered. So now we can select those holes and then we just pocket. It's already through all of it, so that's fine. And if we were to go into here, let me just hide the measurements. If we were to go into here and just slap it on, so let me just pull it up. We take the chassis, just like that. If we were to just slap it on, then it's going to be kind of bad because you can notice that there are those pins down there that if you were to interface with this, it would kind of smash into each other. So like that, you can kind of see how the pins are not gonna do a very good job there. It's gonna cause some issues. What we do is we make a standoff, which essentially is a piece of material that helps create an air gap in between here. So we go back into our CAD model, go into part design, and then we draw up some more stuff. I'm gonna create external geometry so that the circles are accessible and their centers as well. And then I create actual circles just around those. And what I'm going to eventually do with this is I'm going to extrude these circles out. But before I do that, I'm just going to make a circle that matches those inner circles. And what this will do is it's going to create a shape with an area in between the circles. You'll see what I mean by that. All of these have to be same diameter. There we go. And the diameters of those, so let's say 10, sure. And now if we select that sketch, we're gonna see this little donut shape of the two circles, the inner one and then the outer one. The area that's gonna get extruded would be the area in between those two circles. So we're gonna want this to be 15 or something. And then in the A2+, we can select this part that we changed, and then we update, and it should, drum roll please, update. And now we can do our little mating thing. And actually, I don't know why this is so big. Yeah, whatever, I'm just gonna forget about it. And of course you can make your object to look nicer and less sharp on the edges, because that's pretty important as well. So you can select your edges. I'm selecting multiple edges, again, using the control click, and then you can, fillet your edges like that. And then you can just update like this. And of course you can just keep doing this to make something more complex. For the last part of the guide, I'm going to show how the skills apply to an object avoiding robot. A pretty advanced project, at least for, I guess, DIY standards. So this chassis would need to be able to hold a PCB that has all the sensors and the control for those motors. And it would need to be able to hold a power source, which is a 4AA battery holder. All right, so let's jump into the design. Okay, so this is the object avoiding robot, the CAD model of it, the assembly. So if we were to go to the chassis, you could see how I would have drawn this basic shape out from the very beginning. So if we were to go to the pad, it would have been sort of like that. Let me just get rid of all of these other things right here. You can see how it's a pad like this, and then we pocket a sketch. We go down to do that on the other edge, or on the other side. It's for bolt heads and stuff like that. And then we continue to pocket and make changes to this feature, or to this 3D object. We can mirror that feature over here, for example. And then we just continue to keep adding on to this. This is how we would mount the motors. We would pocket some holes for different aspects of the motor to go through, the axle and the cylinder, essentially. So from here, we use a datum plane to mirror this image over here. And then we can fill it like that. And then we use the, there's another datum plane somewhere. We use this datum plane to mirror these two features, to mirror over here. So the mirror of the mirror, I guess. Mirror image of the mirror image. Obviously, this takes a lot longer than just, talking about it. That's essentially the concept of how you would make something like this. And then we could take that, put it in with all of the other objects. I didn't make these wheels or the motors. I basically downloaded them from off the internet, and then I can just import them. Same thing for the wheels, import them into an assembly model. This PCB, I designed in another software called CAD. It's going to be covered in a future video. So now what I can do is I can send this to my 3D printer to have it made. I would just do that by clicking here, Control E to export. And then I can just do chassis like that, export it as an STL, which is a 3D printing file, wherever that is. That should be it. STL mesh. So now I can open this with Bamboo Lab Studio and 3D print it. So there it is. So we have designed a baseplate that can mount a PCB containing an electronic circuit. But how do we make electronics and how do they work? Well, that's what the next video is for, which should allow you to understand electronics concepts and gain the skills needed to make a basic electronics project. In the description, I have linked all the variables of the object avoiding robot project, including the 3D model, the electronic design, and the code if you want to take a look. And also, would you guys like a detailed tutorial on the chassis design of the object avoiding robot project? Let me know in the comments. I'll see you in the next one.